Question 1, 2016, Section B, Question 8, Part B. The Heptathlon is an Olympic competition. It consists of 7 events, including the 200-metre race and the Javelin. The scoring system uses formulas to calculate a score for each event. The table below shows the formulas for 2 of the events and the values of constants used in these formulas, where x is the time taken in seconds or distance achieved in meters by the competitor, and y is the number of points scored in the event. So, for example, for event 200-metre race, x is the time in seconds. This is our formula, y equals a times b minus x to the power c. A is 4.99087, B is 42.5, C is 1.81. And then for the Javelin event, the x is the distance in meters. The formula is y equals a times x minus b to the power c. A is 15.9803, B is 3.8, and C is 1.04. Part 1. In the heptathlon, Jessica ran 200 metres in 23.8 seconds and threw the javelin 58.2 metres. Use the formulas in the table to find the number of points she scored in each of these events, correct to the nearest point. So let's start with the 200 metres. So for the 200-metre race, this is the formula. So we're going to write that down. And then we're going to substitute in the A, B, and C. So we swap the A for 4.99087. Swap the B for 42.5. Swap the C for 1.81, and then we're going to swap the X for 23.8. And into the calculator, that gives us 1,000. So Y is equal to 1,000, so that's 1,000 points she scored. Next, the Javelin. So if this is Javelin, then this is our formula for Javelin. We're going to swap the A for 15.9803. We're going to swap the B for 3.8. We're going to swap the C for 1.04. And then we're going to swap the X for 58.2. Into the calculator, we get Y is equal to 1020, so 1020 points. Part 2. The world record distance for the Javelin in heptathlon would merit a score of 1,295 points. Find the world record distance for the Javelin in heptathlon corrected 2 decimal places. So we go to our Javelin formula, which is y equals a times x minus b to the power c. We write it down. We swap the y for 1,295. We swap the a for 15.9803. We swap the b for 3.8. And we swap the c for 1.04. And x just stays as it is because we're trying to solve for x. We first of all want to get rid of the 15.9803, so we divide. And 1,295 divided by 15.9803 is 81.0373 to 4 decimal places. So we want to solve for x. So one way we can do it is we can say, well, we have to get rid of the power 1.04. So bringing that over the equal sign, we'd get the 1.04th root of 81.0373. And then we would have to add on the 3.8 to balance the equation. Alternatively, what we can do is let what's inside the brackets be equal to another variable. So I'm going to let x minus 3.8 be equal to z. And then I'm going to solve for z. So we have 81.0373 equal to z to the power of 1.04. We can swap them around, so we have z to the power of 1.04 equals 81.073. Then we bring the 1.04 over the equal sign, so we get the 1.04th root of 81.0373. So that gives us z is equal to 68.4343, which is the same thing as x minus 3.8 because both of these are equal to z. So we let them equal each other and we solve for x. So we have 68.4343 plus 3.8 gives us 72.2343, and rounding to 2 decimal places we get 72.23 metres. Part 3. The formula used to calculate the points for the 800-metre race in the heptathlon is the same formula used for the 200-metre race, but with different constants. Jessica ran the 800-metre race in 2 minutes and 1.84 seconds, which merited 1,087 points. If A is equal to 0.11193 and B is equal to 254 for the 800-metre race, find the value of C for this event, corrected 2 decimal places. So we take our 200-metre race formula and we write it down. Y equals A times B minus X to the power C. I'm going to swap Y for 1,087. We're going to swap A for 0.1193. We're going to swap B for 254. We're going to swap X for 2 minutes and 1.84 seconds, which is actually 121.84 seconds. So 2 minutes is 60 plus 60, which is 120 seconds. And then adding on the 1.84, we get 121.84 seconds. So now we just have to solve for C. So we start with what's inside the brackets. 254 minus 121.84 is 132.16. So next we're going to divide by 0.11193. So we get 1,087 divided by 0.11193 gives us 9,711.426, and this is equal to 132.16 to the power C. Next I'm going to rewrite them, just swap them over the other side. So 132.16 to the power C equals 9,711.426. Now I'm going to use my log formula, which states that a to the power of x equals y can be rewritten as log base a y to the power of x. So the a is going to be the 132.16. The y is going to be the 9,711.426. So rewriting, we get log base 132.16, 9,711.426, all to the power of c. So it's basically our scorpion tail method in reverse. So 132.16 to the power of c equals 9,711.426, which is what we had. And into the calculator we get 1.88.